Hey Shrikant, welcome to
Hey,
SigNoz launch week. How are you feeling?
hey, Pranay. I'm feeling good.
Cool. So, I know you have been working on a lot of cool features. So, looking forward to what you are about to share. But let's first start with a quick intro about yourself. What areas do you work on in SigNoz and which features you look after?
Hey, everyone. I'm Srikanth. I majorly focus on metrics and alerting part of the SigNoz. Um, Over the last several months, we have made some great improvements. Welcome.
Cool. Cool. So, let's get started. What are the things you are going to share today with our viewers?
So we have several things to share. They are temporal and spatial aggregation. If you are a long-term SigNoz user, you would know that there's only one level of aggregation per metrics. Going forward, you will have the ability to apply different aggregation on the time axis and different aggregation on the dimensions. And we started adding function support for functions. And for the open telemetry users, we have support for exponential histograms. And same for the again for the open telemetry users who come to use SigNoz, we added support for delta temporality.
Nice. So, this looks quite interesting and quite deeply technical. So, maybe we can start with what we are doing in temporal and spatial aggregation. I think it would be good if you can just share a quick intro on what these terms mean, because some of our viewers may not be aware of that, and how we have enabled this in SigNoz and how users can actually use it and benefit from it.
Um, Right. So if you are a if you are some if you are a application developer or infra person, you would know like your applications keep sending the metric data. There is an interval at which these applications send the data, and these applications, depending on the nature of the application, whether it's a like microservice, whether it's a database, they send the metric data, and then along with that metric data they have these labels which represent some specific set, like annotations are usually referred to as, um, send the metric data. Each of the unique set of labels form a time series. So when you hear a time series, what it represents is a metric name and a set of unique labels. A application can send n number of time series. It can be, it depends on the number of time series. That application depends on the cardinality of the label values. Let's if we say if you just if you just take the consider of the application service name and the http status code. HTTP status code, we know the values, the ranging from 100, like 5 to 100, 500, 400. So the number of unique time series that it generates is around 15. If we just consider HTTP as a status code as a label. And if we introduce a service name, and let's say there's 5 services and 15 possible HTTP status codes, there are 75 unique time series. So when you hear a time series, this is what it represents: a unique set of label combination. Each time series will produce some value. Like take an example of service name frontend and HTTP status code 200. So this is a unique combination. It produces a value. This value is reported at certain intervals. Your metrics are going to give you some aggregated nature. They are not going to, the nature of the metrics is that they will give you the some pre-aggregated data. The front end and the HTTP status code combination will produce value at certain intervals. In the slide that you see, time series, some hypothetical time series T is there. It is producing a value at a 5-second interval. A value is reported at 0th second, a value, and the new value is reported at 5th second and the 10th second, and so on. The temporal aggregation, what it means is, when you look at because it's reporting at a 5 seconds interval, when you look at a larger window of data, we won't be able to show a raw data because there are not as many pixels on the screen. So we need to perform some sort of aggregation on this data and provide a representative value of the data. So let's say if you want to look at 24 hours of data, we cannot show the 5 seconds aggregate, like 5 seconds interval data, because the number of pixels are not there. So we need to aggregate this data to some interval, say 5 minutes or like a minute interval. We will have a 12 values reported. So because it's reporting at every 5 seconds, we will have 12 measurements reported, and we need to use some aggregation type to get a representative value of for that whole minute. If you take a memory as an example, one way to look at it is, even though the reporting interval is 5 seconds and you want to get a value for 1 minute, one way to look at it is, you take an average, or you could take a max. It's up to you, but it wouldn't make sense to sum them, because the sum you cannot, the memory is that it is at the 5th second, 10th second, you cannot sum them. So there is a, depending on the metric type, what it makes sense to you can either take max or average, but you cannot sum them, because if you sum a memory at 5th second and 10th second, it will be more than what you have in the actual memory. So a appropriate aggregation would be either average or max. So the temporal aggregation works on a one single time series, like it works on each time series. We reduce the 5 seconds interval reporting values to 1 minute, because we cannot show as many data points on your screen. We reduce it, and you need a way to combine them. So either you take the average or max, whatever it is, you need a way to aggregate on a time axis. So here you are looking at a time axis, and what you are looking at is, we are reducing the values of every 10 seconds to one single value, so that you can present it in the dashboard and give some sort of aggregate level. This is the concept of temporal aggregation, where your measurements are aggregated on time axis and produce a one single value for some bigger aggregation interval.
Got it. And this aggregation function can be different type of functions. I think, as you mentioned, this could be, for example, these three values. You can take a max of it, or you can take a sum of it, or you can take an average of it. Any type of
Yes,
aggregation function you can apply, right? Is
correct.
that broadly correct? Got it.
Yes, correct. So depending on the nature of the metric, you are the person to decide what makes sense, what is a reasonable
Hmm.
aggregation, but you will be presented with an options to aggregate, like whether you take a max, min, sum, average, latest. Like it's in sometimes maybe you don't want to average also, just take the last value, like any value.
Got it. Hmm. Makes sense.
Yeah, next we have spatial aggregation. It's important to understand this as well, so that as we just discussed, a temporal aggregation works on one time series and reduces the n number of values to a small set of values that can fit on your screen. It is only just for one time series, but modern applications are distributed. You will be getting the same like time series from containers, infrastructure, regions. You don't want to have a value at a smaller one time series level. You need a way to aggregate them across a dimension. So a container name is a dimension, an infrastructure region is a dimension, a service name is a dimension. The spatial aggregation deals with these dimensions. You, at the temporal aggregation level, we work with one time series and reduce the time axis, like the number of points that you get on the aggregation interval. After that, you have the one new series produced for each time series with a with a much more aggregation interval that can fit on screen. Now let's say if we go back here, so this is now you have a 3 points instead of 9 points. Let's just assume that there are four such time series, and then four such time series, each of them produce one value at every 15 seconds, right? Now you want to, let's say, you have a four hosts that are sending data, that are sending a request count. You may want to look at across all the hosts what is my total request count, or you could just say that at this host what is the total request count. And you need a way to, if you work with metrics after the temporal aggregation, one needs a way to work with spatial aggregation. Here you work with the dimensions. Each time series has, you have gotten the temporal aggregation result. Now we apply the new another aggregation on top of the result of the previous step. Here also you get an option to do sum, average, min, max. As we discussed, if it were a request count that you got from the previous step, it makes sense to sum them instead of averaging them, because it's not meaningful to average the request count. You would want to sum them across all hosts and look at a total request count. So this spatial aggregation helps you slice and dice on the dimension axis, so that you get a clear picture of a total versus like on host level, on region level, or on even more granular level, service level.
Cool. So I think we understood what temporal and spatial aggregations are and how that can be useful to users. Shrikant, maybe let's go through a demo on how users can use that. Like, how does our query builder support that today, and how users can actually play with that?
Great. Let me walk you through the demo. This is how the new query builder looks. Um, the you will be asked to you will be asked to you'll be asked to give the metric name first. Depending on the metric name, we fetch the metadata. We know the metric type. Depending on the metric type, we provide you with the sensible time aggregation and space aggregation, so that you can work with it without worrying about the metric type, underlying metric type. For instance, we have a counter metric called calls total, which is counting the number of requests for each service. If I select that as a metric name, you can see that the default here you see two options. One is rate and the other is increase. This is the temporal aggregation, and here you see sum, which is spatial aggregation. These are populated based on the metadata that you send to SigNoz, that this is a counter metric, and the sensible options to include in the temporal aggregation rate and increase. And in space aggregation, you can have your own whatever makes sense to you. If we are interested in looking at the request count for each service, so first we take the rate or increase. Like if you are interested in a rate of request rate, it's just a rate. Or if you are interested in total calls, there may be occasions where you are not interested in the rate, you are only interested in the total request calls. Take the increase and then sum by service name, and you can apply here, and you can see get the data. Here you see an absolute request count at the each aggregation step interval. This is the total request count, and you can go back and change it to rate to get the actual request rate instead of the absolute request count.
So,
You can
Shrikant,
see that.
just to understand it better. When you say rate, it's capturing the difference between two time periods. And when you're saying increase, it's the absolute count. Is that correct?
So a rate is per second rate. It's not, it is true, it is per second request count per second.
Okay.
If you send it for 60 seconds, like if you're sending 100 requests for a minute, the request rate is
Mhm.
100 by 60. That is what we
Okay.
rate here. If you were to
Okay.
use increase, you will get a total count. Yes,
Got it.
that
Got it. Makes sense.
that's for the counter metric. You can have different kinds of metric types. There can be a gauge metric. There can be queue capacity. Like we have own internal collector metric queue capacity. As you notice, the temporal aggregation and the spatial aggregation options have been changed because it does not really make sense to do a rate on a number that is not a counter. So the average is the default that we suggest because the queue capacity, and then you can average by, like if you have a services, you can average by. This is another metric type. If you run it, you get a queue service average size of your queue. That this is the part of the where you can work with the temporal and spatial aggregations. As you see, this is a temporal aggregation, and you can, as a part of the spatial aggregation, if you recall, we discussed the dimensions part. As you can see, temporal aggregations, there is no dimensions area. You are going to take the average. You're going to take each time series and then reduce the high number of points to some representative lower number of points. You get a number of time series with the reduced interval. After that, you want to aggregate across the dimensions. Like dimensions, like ability to select the labels here at the spatial aggregations. Next, I have the function support. If you are a, if you there is a good chance that your metric can be a,
So before Shrikant, before we move to functions, one question I had was, can you apply multiple dimensions on the spatial aggregation? So here you have average by, and here you have chosen service name. Can you have
yes.
multiple items here, or it can be only single?
It can be many. It can be any label that is part of your metric. So if, as you can see here, here you can see number of attributes. Let's say I can say queue size by exporter, each exporter. It can be more than one. It does not have to be just one. So as you can see here, each exporter has its own capacity, queue capacity. One has
Got
higher,
it.
other has lower. It can be more than one attribute. It can be any number of attributes that you're sending as a part of your metric data.
But when you are doing that, what is it averaging on? So if you have two dimensions, is it averaging on which dimension do we know is it averaging on?
When you look at this data, if you see the result set, there is a service name. There's only one service name, SigNoz collector, and then there are number of exporters. If you see, there is a ClickHouse matrix exporter and traces exporter, logs exporter. If we were not to have an exporter ID, it is going to average across all of the exporters. But as
Hmm.
soon as you add the exporter, it is going to be averaged within the combination of the service name and the exporter.
Got it.
Here,
Got
if
it.
you can see that it is combination of SigNoz total collector and the ClickHouse matrix height as the capacity. So the aggregation is among the values of it, like ClickHouse matrix writer and the SigNoz collector.
Got it. Got it. Makes sense. Cool. Let's move to the. I think you're talking. You're going to talk about functions support which I've added. So
Right. So it happens that your metric data can be varying in nature. There are number of things that you want to do with it. Let's say if you have a lot of metric data that is not interest for you, like let's say a queue size, let's say there's a request count, there's a service which is only occasionally gets the request, but it is going to make the graph look very heavy. What you can do is, you can you may want to exclude them. So you may want to have some level of exclusion capabilities. Like, hey, I want to exclude these time series above this range and time series, like, graph below this range. That's one kind of functionality that people would like to have. And the other kind of functionalities, as like, you may want to have some sort of applying some mathematical functions on top of the result set, for any reasons. Let's say if your numbers can be very, very big, you may want to look at the logarithmic value instead of the absolute value. and and there are other kinds of functions where you want to have a moving average to smoothen your curves. Like, certain data points can be like, there can be certain metrics which oscillate between the higher and lower values very frequently. It make your graphs looks very sharp, and you would want to prefer to look at some smoothing functions. We And then there are other functions where you want to compare the current metric data to the same metric and same aggregation, everything, but with the past, how was it behaving in the past. Like, you may have a question, what was the request count for the past duration for the same set of services. So we added four kinds of functions, like exclusion functions, arithmetic functions, smoothing functions, and the time shift, where you compare with the past. Here, I will show the demo for one such SigNoz calls total, service name, run this. Let's see. So here you have a services which are like, 0 point request count. I don't want anything below 15. I can apply a function on this cutoff min. I can apply a function 15, and the services which were below will go away. They will not appear here. That's cutoff functions. And you have
Got it. And I think one of the use cases we have seen for this was, we have heard from our users that, hey, like, I just want to see metrics which may be problematic. I don't want to see metrics which I know are low and they are fine. So they are
fine.
just populating my dashboard and like adding to visual noise. So this
Correct.
helps you reduce the visual noise, because many times our users keep these dashboards open and sometimes project this in monitor and just keep a look on these metrics. So if you just focus on those which may cause a potential issue, that just
Yeah.
helps to focus on things which you want to. Sorry,
Correct.
continue, Shrikant.
Yeah, and the functions can be chained. As you can see here, we have applied the cutoff functions. For the sake of a demo, let's just say you are interested in looking the cumulative value of it, or let's just say arithmetic, like maybe simply log value of it. You can change this function and you can apply. Applying this chaining will apply on the result series of this instead of the underlying data. So you will still see this data, but just that logarithmic 2 applied. And when we run this, you're still seeing the data. As you see, it's now no longer 20. It's now log 2 value of the 20. The
Right.
functions can be chained. And then let's just say you are interested in smoothing functions, or let's just say you are interested in comparison functions. You can create a separate query, do the same thing, but in the past, let's just observe uh, what was the request count for the specific service. Let's just look at only for the front end. Makes it simple. In the request state, service name, front end service name. Here I can apply a time shift function, and I want to compare it against the past data that I enter is in seconds. And when I run this query, you can see I have two lines here, each representing, one is like query A is representing the current value and query B is representing the past value. This can be very helpful when you want to see when there's some issue you want to debug, and then you want to see historical, how did it do when the system was fine. This can become very handy. So this is another kind of time shift function. The next
Yeah.
the Yeah.
Yeah, I think one specific use case I have also seen for this is if somebody has deployed a new version or a release, many
Right.
times users want to compare that what was the same metric looking like before the deployment and what happened to it after the deployment.
Yeah,
So
that
users will say that, okay, this was the point of time I deployed. What was it before? What was it after? And this functions actually helps solve that issue.
right. Next, I want to show the smoothing function as well. Since we are here anyway, we have exponential weighted moving average and the regular median. You can see here I can apply weighted moving average 7, which depicts the window size. Um, oh yeah, here the alpha is missing. I should enter alpha. As you can see, you can apply, you can change the functions on top of the other functions as well. There's no restriction. There's a restriction. We only allow it to maximum of 3 functions chained for now, but these functions chained are applied one after other, so you can use them in any order you may want to. That's about the functions.
Cool. So one question I had was how do we change the order of the functions? Is it so do we have to create that again? Is that the current behavior?
Yes, the current behavior is you need to deselect the previous selection and then apply them again, but a ideal experience would be to rearrange them. uh,
Got it. Got it. Yeah. So maybe this is the first version and
yeah,
we'll
this is the
improve on.
first version. We will iterate on it. Correct.
Yeah. Cool. So I think we saw some pretty cool improvements in the query builder. And frankly, time shifting of functions is something which I have been waiting for a long time. Uh, in I think Shrikant also mentioned about introducing support for exponential histograms. So let's chat about that. What have you done there? How it would help SigNoz users in getting better metrics?
Yeah. So if histograms is a universe, like histograms is the most one of the most important metric types in when you work with when you work with any metric type, because it commonly, the most common use case is to request the latency. Latency is the most important metric on web, because your latency decides the how your user feels. Like high latencies, you don't want your applications to have high latency, and the common ways to measure the latency is to use histogram. The current most popular way to measure these histograms is to use fixed bucket histogram, where you have the buckets fixed upfront, and the measurements will be grouped into these buckets, and then anytime you want to look at a x percentile, you look at the a bucket which represents that percentile, and within that bucket you assume the distribution was uniform and then extrapolate the percentile value. That's a common way. That's a common. The issue with the fixed bucket is that you need to give the buckets upfront, and these buckets must be same across all your teams and services. Then it is important to have these buckets same, because when you want to merge the buckets across systems, they must have the same bucket boundaries, otherwise they cannot be merged. It limits this constraint, and it is also expensive. If you are coming from Prometheus background, the way they are represented, the way they are stored underlying on the storage is a one time series is created for each bucket, and anytime you add a new buckets, it's going to increase your time series. Your queries will become slower, your storage will increase as a result of that. So today, many just limit themselves to very fixed number of buckets. The buckets you commonly see are very, like maybe around 20. The numbers are very fixed. Um, when you want to move to, when you, let's say you want to have a higher resolution, the in a fixed bucket histogram, you will be forced to add new buckets, and as you add the more buckets, your storage costs will improve, your compute will improve, increased, and it becomes much more compute intensive, and it becomes also difficult to manage.
Srikant, so
The
maybe a quick question there. If when you say fixed number of buckets, how is that decided? For example, if I have a
up-
service which is say zero, like whose latency varies from 0 to 500 millisecond, and if I have a service whose latencies varies from say 0 to 5 second, will the latencies for both still be classified in the same set of buckets, or it changes based on the maximum latency which the service has seen?
Yeah, this is the limitation of the fixed bucket. You need to configure the buckets across the services same way. You cannot have different bucket boundaries in, like, because we want to able to merge them at the end.
Hmm.
You cannot have these different buckets for different services, which is limiting in itself. Like, let's say if your application is only 0 to 500 milliseconds, you are
Hmm.
forced to use the same bucket boundaries concept as your service, which may have the 20 seconds latency, and you will lose the granularity because of that.
So if so, are these buckets manually specified by engineers on some file, and
Yes,
then that file is used by all services? Is that how it works, or is this automatically decided that okay, give me 30 buckets from 1 to say 1000, and when you say that, for example, if it's the second case, give me 30 buckets from 1 millisecond to 1000 millisecond, what's the spacing? Is it assumed to be uniform distribution, or how
it
does
is
that
a
spacing?
fixed, it is specified upfront, and it is decided by some either engineers or operator, like whoever is going to operate the service. They
Okay,
need to come up with a some fixed bucket representation, which is not, which is going to which is going to be helpful for both this service that has a higher latency and the service that has a 500 milliseconds. it
got it.
they need to convert, they need to come up with a some representation that works for both of them, which is challenging again, where engineers need to, when you are an application developer who does not want a low granularity at the lower resolution, lower latency, and the other services wants that, you may still end up adding more buckets even though you don't need it. That's the issue with the fixed bucket histogram.
Makes sense. Makes sense.
Yeah. So we have an exponential histogram. This is a new, like a metric type that's open telemetry supports, and this is a kind of current state of art way to represent latency, any distribution data. This, the concept behind this exponential histogram is, you will instead select, instead of specifying the buckets, you will specify the scale. A scale is the underlying thing that tells you what will be the resolution of your histogram. The higher the scale, the more like higher the resolution of your histogram. And this is again, it has the same idea of the bucket boundaries and bucket counts. It is the major difference is that you can configure the scale, and then based on the scale your histogram resolution will be decided. The bucket boundaries in these exponential histograms are factors of this formula that you see, 2 power 2 power uh, negative scale. If we were to, let's just say, a scale of 0, what would be the a factor? You would get a 2 power 1. The factor will be 2. So the bucket boundaries are going to be factors multiples of 2. You have 1 millisecond, 2 millisecond, 4 millisecond, 8 millisecond, 16 millisecond. It goes on. The what you see here represents a latency distribution, latency axis for 1 milliseconds to 100 seconds with a scale of 0. As you can see here, the total number of buckets that you end up with having to represent the 1 milliseconds to 100 milliseconds will be 17 buckets for the scale of 0. As you can see here, at the end you can see the bucket boundaries. There is a bucket boundary 32,000 32 seconds and then 65 seconds. As you can see it here, the difference between them, like the range that the bucket is covering is pretty high, like 32 seconds to 65 seconds, almost twice as much. There is 33, the range that it is covering is very high. As a result, what can happen is the relative error is high. Let's just say, even though your observations, imagine a case where you know the service latency is high, but they are going to be concentrated around 32,000. Like let's just say for they're going to be around 33 seconds, majorly concentrated around 33 seconds. Regardless of that, with this scale, what you will end up having is, you don't know that, like as soon as you group them into a bucket of 33 seconds to 65 seconds, they all are coming under the same bucket, even though they are still around the lower bound. As a result of that, the relative error, so the concept of relative error is, what was it if you were to compute it on raw data, what would be the percentile and what would you get out of this scale. So let's say if the raw data was around 33 seconds, but the computed value is around 40, now there is a difference of 7 seconds, so you lost. It's not very accurate, so there is a relative error that you get out of this scale. The relative error is much higher here in this scale. You may want to have some higher resolution where the relative error is limited. A relative error, you may want to have a lower relative error guarantees, because it's a very sensitive to, if you have an application where 33 seconds is very sensitive compared to 65 seconds, maybe doing some processing, which is twice as much, you want to have some level of relative error guarantees that tells you that your original value versus the estimated value will not be different by so much. This is where the scale helps you.
So yeah, Sikat, the question I had was, do users specify the scale, or do they specify the error boundaries which they're comfortable with, and we calculate the scale at the backend?
If you are open telemetry users, you will be asked to specify the max scale. You can derive the error boundaries that you want to from the scale, like like as you can see from the formula, you can derive it. From a SDK side, you will be allowed to specify the max scale, and the SDK underlyingly it adjusts based on the data it sees. Let's just say if your application is only seeing a maximum, as you mentioned in the as we were discussing earlier, if you have an application which is 0 milliseconds to 500 milliseconds, you want as much granular as possible. Like, so it adjusts the scale. Like, you can have a much higher scale, like let's say
Okay.
a scale of 5, it automatically adjusts depending on the latencies that it sees on the it encounters. You can only you can specify the max scale. The actual scale will be depending on the data, and the SDK decides which is the appropriate scale for the data that it sees.
Got it. And if says two services have different scale, if you want to aggregate across these two services, you will need to do some sort of merging. And because of this
Yes,
binary 2 to the power formula, that merging becomes very easy. Is that
correct.
essentially the got it.
Correct, because because you can do the perfect subsetting, you can rescale the one of your histogram to the one that scale that matches, and then transparently merge them.
Makes sense.
Yeah. So next, this is a very common one that we have seen, like where you have the 17 buckets, which is representing from 1 milliseconds to 100 seconds, very popular one. Next, we have the same thing but with a scale of 2. As we discussed, the higher the scale, the higher the resolution, because your bucket boundaries are factors of scale value. If we choose a scale of 2, you will end up having a total number of 67 buckets. And if you see it in the screenshot, if you see it from the slide, you can see the window between earlier we only had a one bucket boundary for 1 milliseconds to 2 milliseconds and 2 to 4. Now you can see there are 1 milliseconds, 1.1 milliseconds, and 1.42, and then next one comes up is 2. There are now 3 buckets in between them. As a result, you get a more granular, the observations will be put into more granular, and the value that you get when you compute the percentile will be much accurate. You get a, if you look at it, if you plot this as a heat map as well, you get a more representative data of the original data, so you get a higher resolution, and less, your relative error is comparatively less.
Got it.
Next up, we have to show the high can you go and then still get a very good resolution and very less relative accurate error. Next, you have a scale of 5. Here, just to show you what it would look like if you were to choose a scale of 5. As you can see it here, I selected the set of samples from the start, middle, and the end. You can see in the end, if you recall our first example, we only had a 62 seconds and 100 seconds. There's only one bucket them. Now if you see, there's a 94.7 seconds and the 96.7 seconds. So look at the bucket boundaries. The higher the scale that you go with, the more accurate and more higher resolution that you get. This is a very powerful when you are very sensitive to small changes in terms of relative error accuracy.
Got it. What's the flip side of it? So we get a lot of accuracy by increasing the scale. Is the flip side primarily that we need more space to now
Yes.
use this metrics, or are there any other side effects
Yeah,
also?
the major cost that you get, that you will incur because of this is more space, because you are collecting more granular data, you will have more space.
Got it. Cool. I think let's
Yeah.
go for the demo. I think you have some pretty cool demos.
Yeah. So since recently we did a great deal of work to support this. We added support. We are a champions of open source, and we added support for way to support this in ClickHouse and way to their client libraries. Let me show the quick demo where I will show you the. Okay, let's start with a new panel. So here I will show the type of the metric to show you that it is indeed exponential histogram. SigNoz latency. So we collect a span metric called SigNoz latency. That span metric, sorry. So there's a metric name called SigNoz latency, and its type is exponential histogram. We started supporting this exponential histogram. As we discussed, it's more accurate, more relative, gives you a solid relative error guarantees. You can start work with this exponential histograms. Depending on the type of the metric, it has already selected the sensible aggregation. You can now, let's just say I want to look at the latency by service name, look at the P90 latency by service name. Here it shows. To show you that it is more accurate, it is as close to the original data. Let me show you the another query which is based on the original trace data that we used to generate. So let me select the traces, T90 of the duration nano by service name, to show you that it is as close to as the original data, we, and represents a more accurate values. As you can see here, let me add because this is a nanoseconds, let me add a formula. B by as you can see here, they are very close in terms of the higher value and the lower value. The value of the latency that you get from the exponential histogram and the value of the original that you get from the traces, they converge, and then they are very close. This gives you the more higher relative accuracy values. You can start working with the exponential histogram going forward.
Srikant, maybe do you want to just filter for a particular service and then show
Yeah,
me so that it's much more clearer?
yeah, yeah. So let me select the service name customer or something, front end. Select service name content here. Here you can see the values, the latency, the original latency, the one that you see, the one from the exponential histogram and one from the underlying raw data. The values you can see they are largely around the same scale as opposed to if you were to select a fixed bucket histogram, there is a more chance of relative error. This is one great benefit of having exponential histograms is that there is a relative error that is very as close as to the original data source, and you have a much higher resolution when you work with the heat maps.
Do we have the data for fixed bucket also? If we can add that, that might.
Yes, yeah, I can add another query where you have the data. Yeah,
Yeah, and maybe also use the legend format to just make
yeah.
sure that we know what is what. Because this looks pretty interesting. I think many of the viewers may not be familiar with like the intricacies of histogram calculation.
We have a fixed bucket as well, so we remain both compatible. So let's just look at them as well. Service name, service name equals to content. This is fixed bucket. As you can see here, the exponential histogram, wait a second, the raw data, the legend formatting should be formula. As you can see here, the fixed bucket is around 340 and the raw is around 290 and the exponential is around 285. Like I just took a one example. As you can see from here, the difference between the original value and the exponential is only 5 milliseconds, but the difference between the original value and the fixed bucket is 50 milliseconds. If you have a very sensitive latency sensitive application, it's very important to avoid this, like the relative error which is higher. So this as you can see here from here, this is much higher with the fixed bucket, but very close to with very close to the original underlying traces data, raw data, with versus the exponential histogram.
Yeah, I think this is pretty cool. So you can clearly see that the exponential histogram ties much closely to the raw data compared to what fixed
Fixed
bucket
bucket,
does. What
yes.
would be the business implications of this? So suppose somebody is using fixed bucket versus exponential histogram. Where would this maybe hurt them? I'm just trying to imagine scenarios, or why would, because there's some effort, like more as we discussed, there's some more storage cost involved using exponential bucket. But what's the benefit from a
The
like
benefit is
end user
that
perspective? Yeah.
you get a very accurate value, and latency is one of those things where you want to get where you want to storing a raw data would be much higher costlier than exponential. So the major benefit that you get is your value is as close as to the original data and still giving you the accurate. Like here you can see the 50 milliseconds could be very drastic. Like if maybe say you have a SLAs that you honor, that hey, it's never going to be go above the 300 milliseconds, but it turns out that your fixed bucket is telling you that it is 341, although it was 299. It adds these things, like where let's say your developers want to optimize, or whether you want to make sure that you are following, like you are honoring your SLA commitments. It's important to have some number which is as close as the original source, not introduce any like higher relative errors.
Yeah, I think that's a very good example. it can be much better source of truth for determining SLAs.
Yeah.
Cool. So this feature looks quite interesting, and hopefully SigNoz users will like it. I think the last
Yeah.
topic which you mentioned was around delta temporality. We recently added support for delta temporality. Tell us more about like what delta temporality is, how is it different from the current approach, and maybe what are some pros and cons for using delta temporality versus the standard approach.
Right. So the metrics that you send to us can be two ways. They can be delta, or they can be like let's say if you are sending a counter, there can be two, either it's a delta or either it's a cumulative. In a delta metric, what happens is that you report the number, like you let's just say request count. Let's just take the request count as an example. One way to report the request count is report it for each minute interval and then forget about the past, like not worry about the what it was past. Another way to say is that okay, keep count, like keep counting the request and keep it with you and then report the total so far. So one way to say is you can send a counter for each minute, and other way to say it is okay, what is the request that I have seen so far, like this minute, and then next minute. Instead of saying it as what is it for this minute, instead of in delta you will send the measurements for each minute, as an example. In cumulative, instead of each minute, what you say, from the since the starting of the applications, how many requests did I see so far. You no longer do it for each minute. You report these measurements as how many have you seen so far since the start of the applications. It is important to consider which one do you want to go with, because uh, the delta has, like each has its own quirks. The delta is because you are no longer keeping the context of the past, you no longer need to keep them reference. As a result, it is delta is very low in terms of memory footprint. And you may want to, like there you may work with a certain kind of applications which are sensitive to a memory usage. You want to keep the memory footprint as low as possible. In those cases, a delta is your ideal temporality that you want to go with. And this delta is also like supported by many popular backends, like statsd. When you are working with any other time series, it's easier to understand this delta metrics as well. But the issue with this delta is that you need to, anytime you fail to send a for a minute, let's just say you send my values for each minute and you send it to some destination. If for some reason destination is down for more than 5 minutes and you stop losing the data, you lost the data points. Instead, if it were to be cumulative, since you are going to go report the value after the 5 minutes, like the value that you have seen so far after it comes up online, so you still have the count between the first minute and the sixth minute, and you can use the linearly interpolate and assume that this could have been the count. That's the downside of the delta metric. But assuming that you have some sort of guarantees from your backend and you have some sort of retry mechanism put in your place, you should be mostly fine where you will not lose the data.
Got it. So is the main advantage of delta that the application which is sending metrics would need much less memory, and even the application which is processing it, maybe if you're running say SigNoz in your clusters, it would now need much less memory to process the same metrics and generate the same graphs. Is that the memory and resource requirement the main thing, or does it introduce other benefits also?
It introduced the other benefits as well. When you work with this cumulative, you will, when you want to calculate the request rate and when you want to calculate the request total count, you need to subtract them. So you need to get the value at t and value at t minus 1 to get the value of that minute. You have this additional operation that you perform for each time series, and this introduces the more compute work and then memory work, because you are going to group by each time series. This requires the more resource, and then at the processing layer also, using the delta makes it much faster. It's better than compared to cumulative, because you are avoiding that step where you need to take the RAID step at the processing layer and then group by layer.
Got it. And I think popular metric stores like Prometheus today don't support Delta, right? Is
Correct.
that
It
accurate?
is correct. Prometheus does not support delta. It is only cumulative, and you cannot send any delta metrics to cumulative Prometheus. You either have to choose some other backend, or you have to add a layer where you convert your delta points to the cumulative points so that you can send them to Prometheus, which is the
Which
disadvantage.
would need some other processing also if you want to
Processing
do that
layer.
conversion.
Yes.
Got it. So how can SigNoz users use this? Is this by default supported, or do they need to enable something? What
This
is
is
the process?
currently This is currently not enabled by default, but it is available under a configurable flag. You can turn it on by specifying when you run the query service, you can turn it on by specifying enable delta, and it starts to work.
Got it. Got it. Cool. So this is pretty interesting. I think we have done some really deep work on metrics query builder and how we can optimize the uses of storing metrics. And hopefully our SigNoz users will see the benefits of that. What next pieces are you working on? What is exciting you most on, like what you're working on next?
Given we have the base setup, so we have the support for the delta temporality, we have the advanced query builder that supports the temporal and spatial aggregation, we have the functions. Next thing that we are going to work on is enabling the users to send the data from various sources. That's something that people find it very useful, ability to quickly send the work with their data from different sources, applications, databases, infrastructure components. So we're going to work on the integrations and enable you to get your data from various sources into SigNoz very quickly and easily.
Great. So looking forward to see what you build there, and hopefully our community uses the features you have demoed today, and we would love feedback on how you're finding it useful, what more improvements you want, because this is, I think, our first major upgrade on the metrics backend, and would love feedbacks from a community on how this thing goes. Thanks, Shrikant, for sharing this,
Thank
and
you.
yeah, great chatting.
Yeah. Well,
Cool. Bye bye.